Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to have a look at simultaneous equations. As always, any notes that I make during this lesson will be in the description below. So feel free to copy and paste them into your own notes if you want. Okay, we're going to get to the question on the screen in a couple of minutes time, but before we do that, we're just going to build ourselves up to a level where we're able to attack that question. So first of all, we're going to solve this equation. So this equation, just before we go at it, it has one unknown, which is your x. That's the only thing you don't know in the equation. And if we were to count up the amount of equations here, there's just one of them. So one equation, one unknown, we are able to answer this question as a result. If you were to think of this, like scaling this up to simultaneous equations, you'll notice that the simultaneous equations, there's one equation, two equations, and two unknowns, the x and the y. So that's what we're sort of building ourselves up to if you want to keep that in the back of your mind. So to solve this equation, 3x plus 4 is equal to 19. I'm just going to write it out a bit bigger here. 4 is equal to 19. What we are trying to do is get x on its own. So that should be our last line. X is equal to something. Right now we don't know what it is. So what we're trying to do is, I suppose, break away what's attached to the x on the left-hand side of your equation here. So the first thing we're going to get rid of is the 4. And if you think about it, that's plus 4. So we want to make that, I suppose, disappear. So there's a couple of ways of making 4 disappear, like using maths notation and maths symbols and maths operations. But in regards to this question here, that's a plus 4. So making it disappear is the same thing as getting it to 0. So if we take 4 away from that, like 4 take away 4, that's going to give us 0, and it's going to make the plus 4 disappear from my left-hand side. However, this is an equation. It's balanced. So if I take 4 away from my left-hand side, I've got to do the same to my right-hand side. So I'm going to take 4 away from both sides. So on my left-hand side, I'm going to be left with 3x. I could put in plus 0 if I wanted to, but plus 0 is just nothing. So to make this as simple as possible, I'm just not going to write that in. And on my right-hand side, I have 19 minus 4, which is 15. Now, if you'll notice from my first line to my second line, like I've made it easier to work with. There was 3 terms in my first line, the 3x, the plus 4, the 19. Now there's only 2 terms. So I've changed the way it looks. I haven't actually changed like the values of it. I've just changed the way it looks, and I've made it easier on myself. And what we have is that 3x is equal to 15. Now I don't want 3x, I just want 1x. So that 3 there is being multiplied by the x. So 3 times x. So the opposite operation of multiplying, and I'll just do this up at the top here. The opposite operation of multiplying is dividing, and I suppose the opposite thing to addition is subtraction. And the first one there is what we're going to be concentrating on, the multiplication and the division. We want to get my 3x down to 1x. So if I divide this by 3, I'm going to end up with 1x. If I divide my left-hand side by 3, I've got to do the same to my right-hand side. Divided by 3. And as we all know, 15 divided by 3 is 5. And I'll just get rid of my question mark there. So we get our answer, 1x is equal to 5. Now, just an important note, 1x is the exact same thing as x, but sometimes you won't see the 1 written down beside it, because just for simplicity's sake, x is a lot easier to write than 1x. So those two things are the same. They mean the same thing. And I'll just take that away just in case we get confused by that. I don't want that to be there. So we get our answer as 1x is equal to 5, and that's the same thing as saying x is equal to 5. And if we think about it, if x is equal to 5, and if we were to substitute that back in up here, we would get 3 times 5, which is 15, plus 4 is 19, and of course that makes sense, so we know we've done it correctly. So what you've done there is you've solved one equation with one unknown. Now, to make the step up to simultaneous equations, we need to be mindful of a couple of things. First of all, you're not just dealing with one equation, you're dealing with two. And you're not just dealing with one unknown, you're dealing with two. So just to talk through what the word simultaneous actually means. If two things are happening simultaneously, that means they're happening at the same time. So those two equations are happening at the same time. And basically what you've got to try and do is find a value of x and a value for y that works for your first equation, but also works for your second equation. And that's the tricky part. Like, your two values have to be the same, but they have to work for both equations. So there's a fairly logical and procedural way about going about doing this question, and what I'm going to do, first of all, this is the way we're going to set up our simultaneous equations. I'm going to go 2x plus y is equal to 19, and I'm going to go 2x plus 5y is equal to 23. Like what I said a couple of minutes ago, we've got a y there. So just in regards to this question, just to help me out, and you'll see why I'll do this in a minute, I'm just going to put the 1 in front of the y. There. It doesn't change the value of it because y is the same thing as 1y. And I'm going to put my line underneath here. Now what we're going to try and do is we're going to try and combine our two equations in such a way that we end up with one equation with one unknown. So we're trying to sort of, in a way, mash these two things together so that we have something a lot simpler to work with in my next line here. So what you have to be wary of, or what you have to be on the lookout for, is if we were to take my x's together and look at them, we will notice that we have 2x and 2x. They're the same thing. So 2x is the same thing as 2x. If I was to add those together, 2x plus 2x, I would end up with 4x. If I was to add my y's together, my plus 1y and my plus 5y, I would end up with plus 6y. And if I was to add my 19 and my 23, I would end up with 42. Now you'll notice my new equation there in red. I still have my two unknowns there. So that's no good to me. What I want is for one of my unknowns to disappear, I suppose. So you've got to ask yourself, well, if adding doesn't work there, will anything else work? Will any other operation? Would any other operation get rid of either the x's or the y's? I'll just get rid of that red bit there. If addition doesn't work, is there anything else? And you might be thinking, well, let's try subtraction. So what we're going to try and do here is take away my whole second equation from my whole first equation. So we're just going to take this step by step. And before I do anything, I'm just going to make sure of two things. That 2x there is a plus 2x, and that 2x there is a plus 2x. And you'll see why I do that in a minute. Okay, we were going to take away my second equation from my first equation. And doing that, we will end up with 2x take away 2x. We'll end up with 1y take away 5y, and we'll end up with 19 take away 23. So if we break that down into three separate sums, so this one here first, we have 2x take away 2x. If you have 2x and if you take away 2x, that's going to be 0x. And as we know, 0 multiplied by anything is just 0. So I'm not going to put anything there. And that right there, that whole thing, is exactly what we're looking for two of my unknowns to work against each other so that I have nothing left over. Now we still got to sort out the next two parts as well, so don't forget those. So my second part here, I have 1y take away 5y. So 1y take away 5y is going to be minus 4y. And then my last one here, the other side of my equal sign, I have 19 take away 23, which is minus 4. So what we did there was we broke the question down into sort of 3 sums. And when we took the whole of the second equation away from the whole of the first equation, we ended up with this here. And if you remember back to what I was sort of aiming towards at the start of the question, I wanted to come out with one equation and one unknown. Right now we have that. We have one equation, minus 4y is equal to minus 4, and my unknown is the y. So, I'll just write that out again. Minus 4y is equal to minus 4. Now, in order to solve the simultaneous equation, we're not interested in minus 4y. We're interested in y on its own. So, I'm just going to get my navy pen. You might have seen, or you might have seen ahead and seen what I'm going to do here. I'm going to divide this side by minus 4. And if I divide this side by minus 4 in order to get my 1y, I have to do the same on this side here. So what I'm going to end up with is minus 4y divided by minus 4 is just y, or 1y if you want to call it that, there's no difference, is equal to minus 4 divided by minus 4 is 1. So we get that 1y is equal to 1, or y is equal to 1. It means the same thing. And you might say, oh, I've got my answer, y is equal to 1, I'm done. But just be careful, because in this question there was 2 unknowns. Yes, you've solved what your y is, but you also have to find out what your x is. So, our last step, we found out that y is equal to 1, and I'm just going to go on to the next page there. Y is equal to 1. You know that for a fact. You know that in your question, wherever you see y, it's equal to the number 1. So your last job to do is to take that piece of information that you found out and substitute it back into either equation number 1 or equation number 2, whichever one you want. Oftentimes it's easier to stick with the equations without negative signs, and I suppose we're lucky in this question. There are no negative signs at all, so that's fine. Also, substituting it into the equation with the lower numbers also makes your job a small bit easier. So I'm going to substitute y is equal to 1 into equation number 1 for that reason. So y is equal to 1, and I'll just put some arrows here. Sub into equation number 1. You can do equation number 2 if you want, but I'm going to pick equation number 1 because it's easier. Lower numbers. So I had 2x plus y is equal to 19, I think it was. Yeah, that was my first equation. So what I'm going to do is I'm going to sub this fact in here. I know that y is equal to 1. So now I'm going to have 2x plus 1 is equal to 19, and all of a sudden you're back like the first question that we did, one equation with one unknown. I'm going to take 1 away from both sides. I'm going to end up with 2x is equal to 18, and I'm going to divide both sides by 2, and I'm going to end up with x is equal to 9. So just for your answer, like your answer, that's part of your answer there, the x is equal to 9. The other part of your answer is what your y was. So oftentimes it looks nice if you have your x and your y together. And we had our y is equal to 1. So y is equal to 1. Okay, just to recap what we did there. We made sure that at the start our x's were the same, so our 2x and our 2x. More importantly, the coefficients of our x's were the same. So coefficient is number before the x, and the x is called a variable as well. So the thing that you don't know, the fancy name for that, or the proper name I suppose, is the variable. And I'll put those two pieces of information in the description below as well. So we got those two the same. We took one of our equations away from the other. We ended up with one equation with one unknown. We sorted that out, as in we found out what y is on its own, and that was over here. And then at the very end, we substituted that piece of information into our first equation up above from the original question, the one here. And we found out what our x was. Okay, that brings us on to the question that was in the thumbnail of this video. And this question came up in 2014 in the junior cert. So it was a 15-mark question altogether. There was C part I, so this one, simultaneous equations, and then a question that asked you to verify your answer to C part I. And all in all, this was 15 marks altogether. So this part here was 10 marks, and this part here was 5 marks. So we'll walk through those now. So you might notice this is another step up from the question that we did previously. So straight away, just looking at this, you'll notice that if you were trying to come at this question the same way that we did the other one, we cannot go straight into just adding equation number 1 and equation number 2 together, or subtracting them in order to get rid of one of the variables, because 2x and 5x, they're not the same, and minus 3y and plus 9y, they're not the same. So in this question, we have one extra step to do at the start to sort of manipulate one of our equations, or two of them, so that we're able to get one of my sets of variables looking like the other. So I'm going to start the same way that I started my last one. Equation number 1 and equation number 2. And I've got 2x minus 3y is equal to 18. I've got 5x plus 9y is equal to minus 10. And I have my line underneath them. Okay. In this scenario here, what we have to try and do is multiply one of my equations by some number so that one set of my variables match up. So I'm just going to look at the x's first, and we'll walk through what that might look like. And I'll just get my red pen here. Just these two here, my 2x and my 5x. Is there anything easy that I could multiply 2x by to get to 5x? And what I'm thinking is, well, 2x times 2 is 4x, 2x times 3 is 6x, 2x times 2.5 is 5x, but 2.5, it's sort of, you're bringing in decimals, you might even bring in fractions if you want to go with it that way. It's a small bit messy. So I'm just going to leave that for 1 minute. And we'll have a look at the y's. We can concentrate on the y's as well, if like there's no difference in where you start from. In our last question, we started on the x's. I'll just go back because they were easiest to do, because my 2x and my 2x were the same. But if my y's were the same, I could have started there as well. There's no problem with that. So what we're trying to do here, just back to this one, we were trying to line up our variables together, and my x's, they weren't really going to work. There wasn't an easy solution. However, for my y's, we're trying to get the coefficients to look the same. And if you think about it, my minus 3y, and I suppose more importantly the 3, the actual number there, we'll worry about the signs in a minute. 3, if you multiply it by 3, you will get 9. So, I'll just put that in red up here. If there was some way I was able to multiply the minus 3y in my first equation by 3, then I would have a minus 9y, and I'd be able to go at this question the same way that I went through my previous one. And here's the bit you just got to be careful of. And I'll just get rid of my red there, there. We've figured out that we want to multiply the minus 3y by 3, but remember the minus 3y is part of a bigger equation. It's part of 2x minus 3y is equal to 18. So if we are multiplying the minus 3y by 3, we have to multiply everything in that equation by 3 as well. So I'm going to put that over here. I'm going to put a circle around it. So for my new equation number 1, and I'll just go back to my navy pen. For my new equation number 1, if I multiply everything by 3, I'm going to have 2x by 3, which is going to be 6x. I'm going to have minus 3y by 3, which is minus 9y. And I'm going to have 18 by 3, which is 54. So that's my new equation number 1. But if you think about it, I've changed the numbers, like I've changed the way it looks, but I haven't actually changed the sort of the values of it, like as a whole. All I've done is I've multiplied everything by 3. It'd be like saying, I'll just do over here, just to show you why that works. It'd be like saying, well, 2 plus 3 is equal to 5. If I was to multiply everything here by 10, so 2 by 10 is 20, plus 3 by 10 is 30, is equal to 5 by 10, which is 50. The two of these hold true. They're true statements. Just because I multiply everything by 10, yes, there's different numbers there, but the whole equation, like the truthfulness of it, hasn't changed. So that's just something to be aware of. I suppose the point I'm trying to get across is make sure you multiply everything by 3 going across. So we still have our equation number 2 to deal with, and that says that 5x plus 9y is equal to minus 10. Now, in this scenario here, we have a situation where my 9y and my minus 9y and my plus 9y, my numbers there, like the 9s are the same, but my signs are small, they're different. So we're going to attack that next. But getting to this step is probably the hardest part of it. So just to recap, we multiplied our equation number 1 by 3 in order to match up my 9y and 9y in my equation number 1 and equation number 2. Now, what we're going to try and do is, and I'll just take my rough work here away, just so I have some space to work. There we go. What we have to do now is decide what's the best way to get my minus 9y and my plus 9y away from each other. Or in other words, in much better words, try and work them with each other so that we get 0. So if you think about this, and I'm just going to go back to my red pen. In our last equation, or set of simultaneous equations, we took them away. But if we add these two equations together in this scenario here, that will ensure that my minus 9y plus 9y, well, that is going to give me my 0y. So just be careful of that. So what we're going to do is I'm going to 6x plus 5y. I'm going to have 9y plus 9y, and then I'm going to have 54 plus minus 10. So we're going to come to that in a minute. I just want to talk about that last bit. But what we're doing here, just so we're sure, we're adding my two equations together so that my minus 9y in my first equation and my plus 9y in my second equation, that they sort of combine together to give me 0. So starting over in with my x's, I have 6x plus 5y plus 5x even, which is 11x. I have minus 9y plus 9y, which is 0, so I'm not going to put that in. And I've got 54 plus minus 10. And if I was to write that out fully, I'd have 54 plus minus 10. You know that if you have a plus and a minus coming together, that's the same thing. It's sort of the same logic as a plus multiplied by a minus. And we all know that a plus multiplied by a minus is a minus. So I'm going to take those two things out. And we're going to have 54 minus 10. 54 minus 10 is 44. And what we end up with now is that 11x is equal to 44. So 11x is equal to 44. We don't want 11x, we just want x on its own. So I'm going to divide this side by 11 and this side by 11. And you will be left with your answer, which is x is equal to 44 divided by 11, which is 4. Now we still have to find out what our y is, remember? So our next step, we know that x is equal to 4. We're going to substitute that into one of our equations. So into equation, let's see, equation number 1 or equation number 2. Well, it's up to you really. Let's substitute into equation number 1 and we'll see how we deal with our minus sign in the middle as well. Yeah, I'm going to pick equation number 1. So 2x minus 3y is equal to 18. 2x minus 3y is equal to 18. Now I know that x is equal to 4. So I substitute that in. So I'm going to have 2 times 4 minus 3y is equal to 18. I'm going to have 8 minus 3y is equal to 18. If I take 8 away from both sides, so take 8, take 8, 8, I'm going to have minus 3y is equal to 10. And if I divide both sides by minus 3, I'm going to end up with y is equal to minus 10 all over 3. Now you might think, oh, I've gotten a fraction as my answer. Is that okay? And as long as you've done each and every step correctly, you haven't like skipped a step or you haven't done anything silly, then that's absolutely fine. And our next part of our question will see if that is correct. So there's a way of knowing as well. So right now we've got our answer y is equal to minus 10 over 3, and we also have our answer, what did we find out? X was 4. So right now you've gotten your 10 marks. And just to walk back through that question, you multiplied your first equation by 3 in order to get your minus 3y to transform it into a minus 9y, but you made sure to multiply the whole of the equation by 3. You combined your two equations, your new equation number 1 here and your equation number 2, you combined those together, you added them together so that your minus 9y and your plus 9y, you like added those together, so you got 0. You ended up with 11x is equal to 44, and when you divide both sides by 11 there, you get that x is equal to 4. You then substituted that back into your equation number 1 and you found out what y was. Now, last part of the question, verify your answer to C part I. So just to remember our answer for C part I, we found out that x was equal to 4 and we found out that y was equal to minus 10 all over 3. And just in case you're wondering, the minus 10 over 3, oftentimes it's safer to leave that as a fraction. You could put it as a decimal if you wanted to, it'd be minus 3.33333, and the 3 would keep going. But the 10 over 3, leaving it as a fraction, is as accurate as you're going to get it in the least amount of writing. So to verify my answer, verify just means to make sure. And for simultaneous equations, it's just important to do this correctly, I suppose. So for your simultaneous equations, you had 2 equations. And to verify that your answers are correct, you've got to substitute your 2 answers, so your 4 and your minus 10 over 3, into both of these equations, and your answer should make sense at the end. Now, if you remember in my working out in this question, onto the next slide here, we substituted our x is equal to 4. We substituted it into equation number 1. So we know that these two values work for equation number 1 already. So if you're asked to verify a question, you're going to pick the equation that you did not use in this part of your question to substitute your two answers into. So in this part of our question, we substitute into equation number 1. So in order to verify our answer, we're going to have to substitute these into equation number 2. And again, that's because we know that these two answers work for my equation number 1. We have to make sure that they work for equation number 2 now. So my equation number 2 said 5x plus 9y is equal to minus 10. 5x plus 9y is equal to minus 10. What we're going to do is substitute my x and my y into this equation, and hopefully at the end it'll make sense. So we're going to have 5 times 4 plus 9 times minus 10 all over 3 is equal to minus 10. 5 times 4 is 20. Plus 9 times minus 10 over 3, well, plus times a minus is a minus. 9 times 10 is 90 all over 3 is equal to minus 10. 20 minus, well, 90 over 3, that's the same thing as 90 divided by 3, which is 30, is equal to 10. 20 minus 30 is minus 10. Minus 10 is equal to minus 10. I can't go any further on both sides, and if you compare the left-hand side to the right-hand side, I have minus 10 is equal to minus 10. Of course, that statement is correct, so that is your question verified. So the answers that you got in C part II, they work when you substitute them into equation number 2. And just remember that in this part of your question, C part I, you already know that your answers, when you substitute them into equation number 1, that they make sense. So substituting them into equation number 2 makes sense too. Alright, just looking at the marking scheme. This was an old question from 2014, so it's not like the marking schemes, the newer marking schemes, but basically they've done the exact same thing. And I'll just point you in one place here. Your minus 10 over 3 or equivalent. So if you put in your minus 3.33333, well, that's the equivalent thing, so you're not losing any marks there. And just for verifying your answer to C part I, I've just made the point here. You only need to check the equation that wasn't used to find the second variable. So in this case, we only need to use our second equation. And the marking scheme here did the question the same way that we did ours. So yeah, that holds true for the way that we did our question as well. If you're unsure, you could always substitute the two values into the two equations and they should make sense for the two of them. But if you're stuck on time or whatever, it's handy to remember that you're only substituting your two answers into the equation that you did not use in the first part of your question. Alright, just one thing to notice, and then I'll wrap this up. 2x, just going back to the start of this question here. We were lucky in the sense that the minus 3y and the plus 9y, that they sort of lined up together. And all I had to do was multiply my first equation by 3 so that the minus 3y became a minus 9y, and we were able to use it to work with the plus 9y of my second equation. There could be a case where you'd like 2x minus 7y, and like 7, let's say if this was a 7, then you might be in a bit of bother. And if this was the case, you would have to be prepared to multiply your top equation by some number and your bottom equation by some number so that your variables matched up. So in this part here, if we took our x's and if we were to try and to get my 2x and my 5x to look like something. So basically we're looking for a number that both 2 and 5 go into. Well, if we think about the LCM, the lowest common multiple that both 2 and 5 go into, it's 10. So if I wanted to get a 10x from 2x, I would have to multiply all of this by 5. And if I wanted to get my 5x here, if I wanted to get that into a 10x, or if I wanted to multiply it by something to get 10x, I'd have to multiply that by 2. So there could be a case, you could be given a question where it wasn't as easy as the one that we had here, where 3 went into 9 evenly. You might have to multiply both of your equations by something, and 5 and the 2, it doesn't have to be the same number, absolutely not. You just need to multiply your top equation by something and your bottom equation by something else, so that your x's line up, or your y's. In this case we looked at our x's, so just something to be mindful of. So I'll just get rid of that there. All right, my key points here, I've used a lot of the word variable, the word coefficient. Like this is like a step-by-step on how to do the questions, if you want that. And just so we're clear, if I have 3x, 3 is the coefficient, and x is the variable. I'm going to copy and paste that into the description below. I'm not going to go through all of these because I've been talking for, well, nearly 37 minutes. Okay, I think I've covered everything there. If there's anything I've forgotten, I'll put it in the description below. But other than that, that's simultaneous equations, and thanks for watching.